All right, number 3 is the first thing we're going to work, and it is long division with a binomial. So I went ahead and wrote it out. We've got 2x squared plus x minus 3. We're going to see how long or how many times it goes into 2x to the fifth plus x to the fourth minus 41x cubed minus 79x squared plus 27x plus 90. Okay. So I need to make sure. Okay. Just in case I need it. So with long division, you always ask yourself, what do I need to multiply this first term by to get that first term? So I have a 2 already. I have x squared. I need x to the fifth, so I multiply by x cubed. So it makes sense that I need to multiply by x cubed because I'm dividing it by a trinomial, and a trinomial will not go into a binomial, which is why we don't get x to the fourth. Okay. Sorry, that pen is not working. Okay. So I multiply x cubed times all of those, and I get 2x to the fifth. X cubed times x is x to the fourth, and then x cubed times negative 3 is negative 3x cubed. And then we subtract. Okay, so minus, minus, plus. Those cancel out, and in fact, those do as well. If you're uncomfortable with that, go ahead and write down 0x to the fourth, and I'll talk about that. Negative 41 plus 37, or plus 3, is negative 38x cubed. Bring down the negative 79x squared. Okay. If you want to go ahead and do this as a placeholder, you could just go ahead and say, what do I need to multiply x 2x squared by to get 0x to the fourth, and then a 0x squared, or just 0. But that would give me 0x to the fourth plus 0x cubed plus 0x squared, and subtract, and I'm left with negative 38x cubed minus 79x squared, and then bring down the positive 27x. So if you want to, what you can do is just ignore, like if it needs a 0, put a 0 there, or just, it's just not there. And then you can just mark that one out and start right there. Okay, so you could say, what do I need to multiply 2x squared by to get negative 38x cubed, because you end up in the same spot right there. So I need to multiply 2 times a negative 19 to give me a negative 38, and I need one more x. So minus 19x, okay? Negative 19x times 2x squared is negative 38x cubed. Negative 19x times x is negative 19x squared. And negative 19x times negative 3 is a positive 57x. And then we change signs, so we subtract, and that means so it becomes plus, plus, minus. Those cancel each other out, and I'm left with negative 79 plus 19, that is negative 60x squared. 27 minus 57 is negative 30x, and then bring down the 90. So then what do I need to multiply 2 by to get negative 60, and I need a negative 30. And I have x squared, and I need x squared, so we're good. So negative 30 times 2 is negative 60x squared. Negative 30 times x is negative 30x, and negative 30 times negative 3 is positive 90. And then we subtract, which means plus, plus, minus, and I'm left with 0. So the actual answer is x cubed minus 19x minus 30. And there we go. All right. The next problem we're going to work is number 9. So number 9 says, determine if the following are factors of the given function using the remainder and factor theorems. Give the remainder if there is one. Okay. Well, in fact, they all have remainders. It's just a matter of whether or not the remainder is 1. But the factor theorem says that if I'm dividing f of x by x plus 3, then when I do synthetic division with whatever f of x is, at the end, that remainder is the same thing as just saying the function evaluated at the 0 of that, which is negative 3. Okay? So what I know is that the remainder of this equals the function at negative 2. Yeah? So what I'm going to do is I'm going to go to y equals, because this will be on the calculator question, on the calculator portion. And I'm going to type in 6x raised to the 4th plus 29x to the 3rd minus 34x squared minus 131x, and then plus 70, and I'm going to check my function. 70, negative 131, minus 34x squared, plus 29x cubed, and 6x to the fourth. Okay. So, one thing I want to do is go to my table, and I'm going to look at negative 2, because the function at negative 2 is positive 60, so the remainder equals 60. Now, if the remainder is 60, that means when I do synthetic division, that remainder would be a positive 60, which is not 0. So, is it a factor or not? It is not, because the remainder is not 0. Not a remainder, not a factor. Okay, so now on B, we're going to do the remainder equals f of the 0 of 3x plus 7 is negative 7/3. So, okay, that's not as easy on here, but what I can do is just go to second table set, and I can either have it like start at negative 7/3, negative 7/3, and then I just go to the table, and then there it is, it's 0. Or I can go to have it go back to start at 0, and then just do ask. So if you go to independent and go to ask and press enter and then go second table, it looks blank, but I could just type them all in. So like negative 2 is 60, negative 7/3, if I plug that in I get 0. And the fact that the remainder is 0 means that it is a factor. So for this one I want to plug in 1, so the remainder is the function at 1. That's the 0 of x minus 1. So 1, and I get negative 60. So not a factor. And then part D. Part D, the remainder is the function at 7/6. So the function at 7/6, so I just type in 7/6. And I get, and I'm actually going to go over there and just make sure, so it's negative 71.94 repeating, that is the remainder, which means it's not a factor. Now, this is not multiple choice. I mean, it did turn out that only one of them was, but, I mean, that's not necessarily going to be true on the test. What I'm asking you to tell me is, for all of these, are they factors? And if they are, great. If they're not, then what's the remainder? Okay? And so you have to tell me what the remainder is. You actually have to write that down. Okay. Let's go to number 13. So on number 13, you got a difference of perfect cubes, and I know that 3 cubed is 27, and 4 cubed is 64. So I can rewrite this as 3x cubed minus 4 cubed. And I want to know when this equals 0. I want to find the roots. Okay. So, if I remember the formula, a cubed minus b cubed, then I can fill it in. So don't forget that whatever the sign is right there, that's the same. And then whatever that is, so that's the same. This is the opposite, and that's always plus right there. Okay? And then as far as filling them in, you drop the powers of 3, and that is a and b. And then to fill in this one, you just do the first one squared, so a squared. The middle term is those two times each other, ab. And then the last one is b squared. Okay, so let's do this. I've got my signs. I've got minus, so minus, opposite, always positive. I said positive. Okay, and then I drop the powers of 3, so that's just 3x, and that's just 4. Now, in this first term, I have to say this squared. 3x squared means 3x squared, not 3x squared, okay? It's this, which is 9x squared. Alright? Now, for the middle term, I got to multiply 3x and 4, so 3x times 4 is 12x. Don't take the negative with it, we're not worried about that. And then the last term is the last number squared, so 4 squared is 16. Okay, now I'm trying to solve, so I set this equal to 0, 3x minus 4 equals 0, add 4 and divide by 3. So 4/3 is one of my answers. And then this one I need to do the quadratic formula. So I've got x equals negative b, so negative 12, plus and minus the square root of b squared. So 12 squared minus 4 times a times c, all over 2 times a. So I'll work it out as if I don't know the little tricks, but then I'll show you the tricks just in case. Okay, so I would go 144 minus 4 times 9 times 16, and I would get negative 432. And that's what that is, so 432. So, okay, when you think about your list of perfect squares, let's see, 432, well, I'll just go down the list. 1 squared, 2 squared, 3 squared, and yes. So 81, 10 squared is 100. I'm sure it's a very interesting video right now. Just writing out my list. 169, 14 squared is 196, I'm pretty sure, yeah. 15 squared is 225, okay. 225 definitely doesn't go into it. 225 times 2 would be 450, so past that, that's a definite no-go. Okay, so 225 does not go into it. 196, if I divided it, it does not go into it. 169, if you're unsure, then check it. Divided by 169, and that's a no. And then 144, so if you're unsure, check it. 432, ooh, divided by 144, and I get 3. So this is actually 144 times 3, and then make it a negative 144, okay? So here was the trick that I told you about, though. And then we'll finish up the problem. This is 144 minus 4 times. This is always going to be the same thing as that, 144. So if I have one 144, and I want to take away 4 144s, I got another 144 and then another 144, right? So one of them minus 4 of them, so 1 take away 1 of them is just negative 3 of them. Okay, so really it's just negative 3 times 144, but whatever. Okay, so I get negative 12 plus and minus the square root of negative 144 is 12i, so 12 square roots of 3i, and the 3 stays inside, all divided by 18, and then 12, 12, and 18 all divide by 6, so I've got negative 2 plus and minus 2 square roots of 3i all over 3. And that is, those are all of my answers. I've got 3 answers, 3 power of 3, so 1 and then 2, 3. Okay. Number 15. Number 15 is, it's quadratic form, so what I have to do is factor it as if it was a quadratic, but then remember the powers. So, okay, I'm looking for the factors of 54 that add up to negative 29, and they are negative 27 and negative 2. So, I write this as, normally I would write x minus 27 and x minus 2. But, because it's a power of 6 and a power of 3 and a power of 9, this is actually a quadratic form. It's just, whatever that is, this is half of that. Or whatever the middle term is, that's that. Okay? So, technically there are 6 solutions to this. But, I'm only going to be able to find 4 of them. You could actually find all 6, but I'm not going to make you do that because this one's kind of weird. This is not, 2 is not a perfect cubed. It's not like a whole number raised to a third power. It's the cubed root of 2 cubed, but we don't need to worry about that. So for this one, we just set that equal to 0, add the 2 over, and then take the cubed root. And so then there's one of my answers. I don't do a plus and minus because it's not an even root, it's an odd root. So there's one of my answers. One of those 3. I can't find the other 2, so whatever. Now this one is actually a difference of perfect cubes. That is x cubed minus 3 cubed. So when I solve that, I'm going to go ahead and use my difference of perfect cubes formula and then go from there. Okay, so drop the powers of 3. So x minus 3. The first one squared is x squared. That one's minus, so this one's plus. The middle term is just those two times each other, 3x. The last one is always plus, and then that's 3 squared, so 9. So same thing, just drop the powers. That one times itself, that one times that, and then that one times itself. Okay? So then this answer is just 3, which you would get from over here. If you said x cubed minus 27 equals 0, and then you said x cubed equals 27, x equals the cube root of 27, and you said, okay, the answer's 3. You would get that 1 or half point for that answer, but you wouldn't get all the points for recognizing it as a difference of perfect cubes, factoring it, and then solving both, right? So for this one, I need to do the quadratic formula. Okay, so x equals, maybe not with that pen, okay, x equals negative b, so negative 3, plus and minus the square root of b squared. B squared is 3 squared, which is 9, minus 4 times 1 times 9, all over 2 times a, which is 1. Okay, now again, this is 1 9 minus 4 9s, or you can just say 9 minus 36 is negative 27, and negative 27 is negative 9 times 3. But like I said, 1 9 minus 4 9s is negative 3 9s. Okay, so negative 9 times 3, which means negative 3 plus and minus the square root of 9 is 3. Leave the 3 on the inside, that 3. And then I've got an I because of the negative, all divided by 2. Okay, so I've got 1, 2, 3, 4 answers that I can find easily. Okay, number 17. So number 17 is where we sketch after we find the zeros and think about their behavior. Okay, so one of the zeros is positive 1/2 with a multiplicity of 3, which means it crosses with a wave. One of the zeros is positive 4 with a multiplicity of 1, which means it crosses straight through. This is negative 3 with a multiplicity of 6, which means it bounces. And this is negative 8 with a multiplicity of 1, which means it crosses straight through. Now, I do have a negative 3 in the front, but there's no x, so I don't have a 0 of 0. Okay. Now, I do need the degree. The degree is where I add up the multiplicities. So 3 plus 1 plus 6 plus 1. 3 plus 1 plus 6 plus 1. And that is 6, 9, 10, 11. So that's an odd degree. But my leading coefficient is negative. So of the 4 options on in behavior, you've got up, up, down, 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 up, and up, down. Of the 4 options, I know that it's odd, so it's not the evens, which are up, both going in the same direction, and it's a negative leading coefficient, which means it's the one that starts from above and in general goes down. So I know I start up here and end down there. Okay, now I just need to label my zeros. 1/2, and it crosses with a wave. I do expect you to label that as 1/2 and all of them as the number that they are. Positive 4, which means it crosses straight through. Not which means, but and it crosses straight through. Negative 3, which bounces, and negative 8, which crosses straight through. It's very important that you draw those above, or you really keep track of it, because if it's in the wrong spot, it really can mess it up. And it can actually make it hard for you to actually end up in the right spot. Okay, so I know I need to cross straight through, so I'm just going to kind of, in my mind, go through it. Cross straight through, bounce, come back down, and then I need to cross the wave, and then I need to go back down, right? So I'm going to cross straight through. Gotta give myself enough space. It looks like I was just going straight forward, so I need to be careful. And then I need to bounce. So bounce off it. Come back and be prepared to cross with a wave. So I pretend like I have another max there, and then I just keep on going as if it was a min. And then I need to come back down and cross straight through. And there you go. Okay, I'm going to be picky that you actually cross and bounce at those numbers that you labeled, so make sure that you're precise as much as possible. Okay, the next number. Number 19 says find all possible rational zeros for each function and then find all the real. Okay, or find all zeros, not all real. Okay, so I need the factors of the constant, which are 6. Factors of 6 are 1, 2, 3, and 6, divided by the factors of the leading coefficient, which is 1, which means those are my possible rational roots. So they're only whole numbers possible. So I go to y equals, and I type that in. X raised to the third plus 6x squared minus 29x plus 6, and zoom 6. Remember, only whole numbers are possible, and it looks pretty clear that positive 3 is a whole number, whereas those are not. Okay? So, I'm thinking that I'm going to do synthetic division with a positive 3. Alright, so 1, 6, negative 29, and 6. So, bring down the 1. 3 times 1 is 3. 6 plus 3 is 9. 3 times 9 is 27. Negative 29 plus 27 is negative 2. 3 times negative 2 is negative 6, and 0. Alright, so now I'm left with x squared plus 9x minus 2 equals 0, and I need to solve for the remaining roots. I know they're not imaginary, they're just irrational. So you can either, it doesn't factor, there aren't factors of negative 2 that add up to 9, so I either need to complete the square or do the quadratic formula, and because that's not even, the simplest way is to go ahead and do the quadratic formula. X equals negative b plus or minus the square root of b squared, which is 9 squared, which is 81, minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a, which is 1. Okay, and when you think about this, it's 4 times 1 times negative 2, which is negative 8. You're minusing a negative 8, or you're saying negative 4 times negative 2, which is positive 8. 81 plus 8 is 89, and 89 does not divide by any perfect squares, so negative 9 plus and minus the square root of 89 over 2. So that and 3 are my answers. Okay. Number 21. I need the factors of the constant 24 divided by the factors of the leading coefficient, which is 3. So those have a lot of factors. Well, a lot of things are going to simplify. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24, divided by the factors of 3, which are 1 and 3. So let's start listing them out. 1 divided by 1 is 1. 1 divided by 3 is 1/3. 2 divided by 1 is 2. 2 divided by 3 is 2/3. 3 divided by 1 is 3. 3 divided by 3 is 1, which we already have. 4 divided by 1 is 4. 4 divided by 3 is 4/3. 6 divided by 1 is 6. 6 divided by 3 is 2/3, which we already have. 8 divided by 1 is 8. 8 divided by 3 is 8/3, which we do not have. 12 divided by 1 is 12. 12 divided by 3 is 4, which we already have. And 24 divided by 1 is 24. And 24 divided by 3 is 8, which we already have. So in total, you should have 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 24 possible. So let's sketch it, or graph it. So 3x raised to the 5th minus 10x raised to the 4th minus 27x raised to the 3rd plus 64x squared plus 54x, and then minus 24. I'm going to go back and check just to make sure. 3x to the 5th minus 10x to the 4th minus 27x cubed plus 64x squared plus 54x minus 24. Okay. So I'm going to go to the graph. Zoom 6 is what my window already is, so I need to zoom in. Okay. Okay, I have a degree of 5 and I see 5 roots, which means none of them are imaginary. But they all are kind of in different spots. I see -1. I see 1, 2, 3, 4. So I'm thinking -1 and 4. And then I see this one, and that one. So I'm going to zoom in a little bit and go from there. I'm going to go from -3 to +3. Okay. Alright, when I look at my list of options, I mean, I don't know if you noticed this, but here's the y-axis. Those look pretty symmetrical, which leads me to believe that they're probably a plus and minus something. We already said that's -1. So I'm thinking, like, just looking at my options, I don't have any halves, and those are closer to a half of them, but it's really, like, if I did that, that would be 1, 2 and a third. I don't even know if we have 2 and a third. We don't, because we have 4/3, which is 1 and 1/3, and we have 8/3, which is 2 and, well, we have 2 and 2/3, not 2 and 1/3. So I'm thinking +1/3 is my other option. But let's see. If it's not, then we'll go from there. Okay. So first I'm going to synthetically divide out -1. I've got, what was -1? Yeah. 3, -10, -27, 64, 54, and -24. 3 times -1 is -3, -13, +13, -14, +14, 78, -78. -78 plus 54 is -24, +24, and 0. Okay. Now I'm going to do the 0, 4. 3 times 4 is 12. -13 plus 12 is -1. 4 times -1 is -4. -14 minus 4 is -18. 4 times -18 is 40 plus 32, so 72. So -72, which leaves me with a 6, and 4 times 6 is 24. Okay. And now I do 1/3. 1/3 of 3 is 1. -1 plus 1 is 0. Anything times 0 is 0. -18 plus 0 is -18. And 1/3 of -18 is -6. And so we're good. Okay. I need to find all of them. I found 3 of them. I've got 2 more to find. So I've got 3x squared minus 18 equals 0. So then I add 18, divide by 3, and 18/3 is 6. So x equals plus and minus the square root of 6. -1, 4, and 1/3. You don't have to write those out because you've already proved that they are zeros, but it is kind of nice to have them all in one spot. Okay, last one, let's do number 32. We're going to divide out a bunch of things. Okay, let's see. Trying to decide if I want to do the square root first or the imaginary part first. I mean, okay, I posted, like, I've already posted the answers. I think I'm going to do the 3 plus 2i first just to show you. Well, I don't know. I guess I'll do the video to go along with what I posted, so I'll do the square root of 5 first. Okay, the first time I did it, which was really annoying, I did what people do, and I forgot to check the power. 6, 4, 3, 6, 5. I don't have a 5th power. So, I'm going to do square root of 5, and I've got 1, -19, I just did it again. 1, 0, -19, 24, 187, -120, and -585. Okay, so here we go. Drop the 1. 1 times the square root of 5 is square root of 5, and the square root of 5 plus 0 is square root of 5. Square root of 5 times square root of 5 is just 5. Negative 19 plus 5 is negative 14. Negative 14 times the square root of 5 is negative 14 square roots of 5. And so this is when it starts doing the binomial. 24 minus 14 square roots of 5 is just 24 minus 14 square roots of 5. You cannot combine those. Please don't. Okay, now I need to multiply. Square root of 5. Just kidding. Yeah. Well, whatever. I guess you don't really need. Just see that you multiply it out, but whatever. That times that is 24 square roots of 5. And that times that is, okay, so square root of 5 times negative 14 square roots of 5 is 5 times negative 14. So 5 times 10 is 50, and 5 times 4 is 20, so negative 70. Okay? 187 minus 70 is 117. Plus 24 square roots of 5. Okay, square root of 5 times 117 is 117 square roots of 5. Square root of 5 times 24 square roots of 5, so square root of 5 times 24 square roots of 5 is just 5 times 24. 5 times 20, 5 times 2 is 10, so 100, 5 times, and then 4 is 20, so 120. Which means those cancel out, and I'm left with 117 square roots of 5. So then square root of 5 times 117 square roots of 5 is really just, as you can tell, 117 times 5. So I'm going to put it down there and just work it out. 5 times 7 is 35. 5 times 1 is 5, plus 3 is 8. And 5 times 1 is 5, so that is 585, which gives me a remainder of 0. Okay, now we're ready to do the negative square root of 5. So negative square root of 5. So drop the 1. 1 times the negative square root of 5 is negative square root of 5, which leaves me with 0. Anything times 0 is 0, so that's a negative 14. Negative 14 times negative square root of 5 is positive 14 square roots of 5, which means those cancel out, leaving me with 24. 24 times the negative square root of 5 is negative 24 square roots of 5, which cancels out, leaving me with 117. And 117 times the negative square root of 5 is negative 117 square roots of 5. Okay, now I'm ready to do the 3 plus 2i. So 3 plus 2i. Okay. Drop the 1. Anything times 1 is itself, so 3 plus 2i plus 0 is just 3 plus 2i. And now I've got to multiply those out. So 3 plus 2i times 3 plus 2i is 9 plus 6i plus 6i plus 4i squared, which is a negative 4. Okay, so 9 minus 4 is 5, and 6i plus 6i is 12i. Okay, negative 14 plus 5 is negative 9, so negative 9 plus 12i. Now I've got 3 plus 2i times negative 9 plus 12i, and so I multiply it. 3 times negative 9 is negative 27. 3 times 12i is 36i. 2i times negative 9 is negative 18i. And 2i times 12i is 24i squared, or negative 24. So 24 and 27 add up to 51, negative 51. So negative 51. And then 36i minus 18i is 18i. And 24 minus 51 is negative 27, because we just 24 plus 27 is 51. So negative 27 plus 18i. And now I need to multiply those two out. So 3 plus 2i times negative 27 plus 18i. 3 times 27, negative 27 is negative 81. 3 times 18i is 30 plus 24, so 54i. 2i times negative 27 is negative 54i, which means they cancel out. And then 2i times 18i is 36i squared, which is negative 36. And if you add those two, then you get 7 and then 8 plus 11, so negative 117. Okay. And I am still not done. So now I'm going to multiply by, or not multiply, divide out 3 minus 2i. Okay. So, bring down the 1. 3 minus 2i times 1 is 3 minus 2i. Those cancel out, leave me with just a 6. 3 times 6 is 18. And negative 2i times 6 is negative 12i, which is just a positive 9 when I add them together. 9 times 3 is 27, and 9 times negative 2i is negative 18i, which gives me a 0. And so I'm left with x squared plus 6x plus 9 equals 0. Okay, you could complete the square, you could do the quadratic formula, you could, but you should always check to see if it factors. Are there factors of 9 that add up to 6? Yes, there are. 3 and 3. So there's x plus 3 and x plus 3, which means my final answer is x equals negative 3, negative 3 with a multiplicity of 2, plus and minus the square root of 5, and 3 plus and minus 2i. Okay? If you had done completing the square, then you would have moved the negative 9 over. You would have said x plus 3 quantity squared, then you would have added 9 to both sides, because 3 squared is 9. And that would have given you 0, so then, okay, the answer is negative 3. So there you go. Or if you've done the quadratic formula, x equals negative b, so negative 6 plus and minus the square root of b squared, which is 36 minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. 36 minus 36 is 0, so it is just negative 6 divided by 2, which is negative 3. But it's very important to note that it had a multiplicity of 2, and you do need to state that because now you have your total 6 roots. 1, 2, 3, 4, 5, 6. Okay, I hope that helps, and I did post the whole review done, so just don't forget what is on the calculator versus the non-calculator. Well, I guess don't. Well, let me see. I kind of went through this with my 8th grade class, so I will kind of go through it with you right now. Okay. Numbers 1 through 3. It could go on either. It's probably going to go on the non-calculator as long as I keep the numbers small, so I'd probably keep them smaller than that, but yeah, that would be a non-calculator. Could go on both though. Synthetic division could go on either. As long as the numbers are small, I'll keep it on the non-calculator, but if I want to make it kind of weird, or if I want to do fraction, I don't want to stress you out, then I'll put it on the calculator. And number 9 is definitely calculator, so that's not going to be until Friday. 10 through 15. 10 through 15 are probably going to be on non-calculator, so that would all be stuff that you would expect. I would expect you to do. So I don't know that I'll use necessarily numbers as large as that, because I wouldn't expect you to be able to do that. But I mean, I've shown you how to do it by hand, but if you're more dependent on that, then that would be kind of annoying. So that would be non-calculator, and then definitely non-calculator on 16 and 17. 18 through 21 could go on either. If I give it to you as is, then it would be a calculator. If I give it to you with a picture of the graph, then it would be on non-calculator, and the numbers would stay small. 22 would be on non-calculator. 23 through 27, it could go on either, because really it's just a matter of multiplying. So if the numbers are small, then I might put it on the non-calculator. But I might put it on both, like one of each type on both. But I'm not going to be doing where you have to multiply out 5 things. I'm just not going to do that. Too much. I'll go ahead and do 28 through 33, or 30, yeah, 33. I want to say mostly calculator, but I may put something on the non-calculator, something small. I don't know. I'm leaning towards calculator, but maybe one on the non-calculator, but it would be an easier one. Okay, study.